Hi, my dear students. Today we are going to discussing the Unit 3 Basic Components of Electricity. I hope all of you know about this topic. What is the basic component of electricity? Yes. What is that? Battery. Yeah, very good. You know that mostly all the electric equipments having what? Battery. Without battery that not work. Yeah. So what is battery? A battery is a collection of several cells where a cell is unit of a battery. So battery is a collection of several cells. Okay. So the basic unit of battery, yes, that is cell. And battery is a small source of electricity where electrical potential is produced due to chemical reaction. It provides us current which remains constant with time. This current is called what? Yes, DC. What is that? DC, direct current. Actually, this battery or a cell that is a storage of electricity. Okay, storage of electricity. So the main and the electric generator provide as the alternating current. So alternating current, which means what? That is a AC. AC changes its magnitude and polarity with time. Every electrochemical reactions has its limits of producing electric potential difference between two electrodes. That is what? Anode and cathode. For achieving desired electric potential difference across the battery terminal, multiple number of cells are to be connected in series. When in a battery, positive terminal of one cell is connected with the negative terminal of succeeding cell, then the cells are said to be connected in series. In this connection, overall EMF of the battery is algebraic sum of all individual cells connected in series. But overall discharged current of the battery does not exceed the discharged current of individual cells. Now see the parallel and series connection of battery. Now you know about what the series and parallel connection. This is a series circuit. Series circuit, how it's work, that's we already discussed. Series, the positive terminal of one cell is connected with the negative terminal of succeeding cell. Then the cell are said to be what? Yes, in series. So in this connection, overall EMF of the battery, that is algebraic sum of all the individual cells that is connected in series. Okay, so the overall discharged current of the battery does not exceed the discharged current of individual cells. Next is parallel. Parallel circuit is that all components are connected between the same set of electrically common points. Okay, that is what parallel connection. So this configuration that provide current. Is it clear? Okay. So I hope all of you understood this topic. Okay. Now we are going to discussing safety. You know that safety is most important, no? Now these times, you know that we are always wearing what? Mask and sanitizing our hands and always keeping social distance, no? Yes, for what reason? Yeah, for safety from some virus. Okay, not only from virus, we need a safety from all the electric equipments also. So here we are going to discussing some safety components. So you know that electric currents heats up object to which it flows. Okay, so it get a damages. It get a damages. So how this get a damage? Yes, overloading. As overheating result in damage. Okay. Yeah. So, sir, we are using what the iron box and the bulbs and the geysers, TV, refrigerator and AC, each and everything we are using. No? Yes. So, these excess current that will heat and this produces what? Fire. That will be get about fire. So, we need some safety. So, for this safety, we are using what? Electric fuse. What is it? Electric fuse. What is this electric fuse? What is this electric fuse? A fuse is a safety device which breaks the circuit if the current is too high. Okay. Actually, you can able to see inside there is a fuse wire that is non-combustible material. Actually, that is non-combustible material. Okay, clear? Yeah. So, this protects the cable from overheating and catching fire. This protects the cable from overheating and catching fire. See the simplified circuit. And sockets and extensions that are overloaded with appliances are especially at risk of catching fire. Risk of catching fire. All UK plugs are fitted with fuse and fuse are available in a range of amperes of suit different current values. So how does a fuse work? A fuse is connected directly into an electrical circuit if the electric current surges to a dangerous level. The metal in the fuse melts and the circuit is broken, preventing overheating wires in the walls of the house from starting a fire. Never substitute a fuse of greater capacity than that specified for a particular circuit. If the fuse has ability to carry more current than originally designed, the wire will heat up before the use of metals and this could start a fire. Now we are going to discussing the next one, that is miniature circuit breaker. What is this miniature circuit breaker? A circuit breaker is a automatically operated electrical switch designed to protect an electrical circuit from damage caused by excess current. Typically resulting from an overload or shortcut circuit, its basic function is to interrupt current flow after a fault as detected, unlike a fuse, which operates once and then must be replaced. A circuit breaker can be reset either manually or automatically to resume normal operation. Next, construction of circuit breaker. An MCB embodies complete enclosure in a molded insulating materials. This provides mechanically strong and insulated housing. Okay, so the first word point, that is incoming terminal, and this red box, that is what? Arc chute. What is it? Arc chute. Is it clear? Yeah. And the next third one, that shows, that is bimetallic strip. What is that? Bimetallic strip. Okay. And the next is that coil, that is what? Magnetic coil. What is it? Magnetic coil. Okay. And the magnetic coil that's connected, otherwise that's another end, that is what? Yeah, copper bride. Copper bride. Okay. And the copper bride, then afterwards there is a on off switch, that that the on off switch. Okay. And the last, that is what? Outgoing terminal. What is that? Outgoing terminal. Okay. So this is what the structure of, otherwise that parts of MCBs and working principle of MCB. The most important thing that circuit breaker is doing is to safely and reliably switches off electrical circuit during abnormal conditions of the network. That means overload condition as well as faulty conditions. Okay. So see the connection, how the electricity pass through that word, otherwise how it's work. See the input current. Okay, when the current start to pass through the MCB, that is input current, and it is contact point. So that point is what? Contact point. Okay, and that is comes through where? To the magnetic coil. So the switch is on. Switches on. And now that what? That electricity pass through the bimetallic strips to what? Current flow. That means the out current flow. Okay, through this, like this way, what the electric current, otherwise the current loaded in the MCB. Okay, clear? Yeah. And the, like this way, the electric current loaded to the MCBs. Did you understand? Did you understand this topic? Okay. And the next is types of miniature circuit breaker, that means MCBs. MCBs are classified into three major types according to their instantaneous tripping current. They are type B, type C, type D. B, C, D MCBs. Okay. So first we are going to discussing which one? Type B. Type B MCB. How this type B, what is this type B MCB? This type of MCB will drip instantly at a rate of 3 of few times its rated current. These are normally used for resistive or small inductive load where switching surges are very small. Therefore, these are suitable for residential or light commercial installation. Okay, yeah. And the next type, that is C. This type of MCBs will drip instantly at a rate of 5 to 10 times its rated current. These are normally used for high inductive loads where switching surges are high, such as small motor and fluorescent lighting. In such case, type C MCBs are preferred to handle higher values of short circuit current. Therefore, these are suitable for highly inductive commercial and industrial installation. Okay, and the next is type D MCB. This type of MCB will drip instantly at a rate of 10 to 25 times its rated current. These are normally used for very high inductive loads where high rush current are very frequent. These are suitable for specific industrial and commercial applications. The common examples of such applications include X-rays machines, UPS system, industrial welding equipments, large welding motors, etc. So I hope all of you understood this MCB. Yeah, what is the full form of MCB? Miniature circuit breaker. Okay. Next we are going to discussing earthing or grounding. Earthing or grounding. What is this earthing or grounding? Actually, the electric appliances such as oven, heaters, stables, fans, toaster, refrigerator, electric irons, etc. are frequently touched by us with bare hands. If by any chance the insulation of any of such appliance smells such that the bare wire touches its metal casing, then the person touching them will receive a severe electric shock. It is because the electric potential of the metal casing will be same as that of the applied potential. Thus, electric current will rush through the body of to the earth and is doing so affect the nervous system, which will cause death. To avoid such situations, metal casing of all such appliances are earthed. So what is earthing? Earthing we means that the metal body of the appliance is connected to a thick copper wire which is buried deep in the earth, and its other end is connected to a copper plate surrounded by a mixture of charcoal and common salt. So this is what earthing. And the earth we can earth that can be regarded as a electric sink. So Earth is regarded as a what? Electric sink. It can receive any amount of electrons, but its potential remains zero. So how does earthing help as appliance? Yeah. So the magnitude of the current in the circuit of a short circuit appliance suddenly rise so to very high values. This rise in magnitude of the current in turns overload the circuits and hence the fuse in that circuit melt. Okay, so on melting of the fuse, the short circuit appliance will not receive any current and hence the user is protected from receiving an electric shock. Moreover, the appliance itself is protected from burn out, etc. So this is what earthing. And next, live wire, neutral wire and earth wire. The electric cables coming to a house consist three separate and insulated wires, namely wire, live wire or phase wire, neutral wire, and earth wire. The neutral and earth wires on the supply end, that means power stations, are connected together so that both of them are at zero potential. Inside the house, the live and neutral wires are connected to the input terminals of kilowatt hour meter, whereas earth wire is connected to the body of the kilowatt hour meter in order to distinguish which wire is live or neutral or of earth. The insulation is given a specified color. The old convention for color is red for live wire or phase wire, and black for neutral wire, and green for earth wire. According to the new international convention, brown is for live wire, light blue for neutral wire, and green or yellow color for earth wire. Okay. You know that the electric current is a flow of electric charge. Conventional current flows from the positive terminal of the power source to the negative terminal. In electric wires, charges is carried by negatively charged electrons. They are free to move from atom to atoms in metals. These move in the opposite direction to the conventional current. A lot of mind's power devices need three wires to work safely. Not only two of the wires are used when the device works properly. They are the live, that means brown, live wire, that is color what? Brown color, and the neutral, that is light blue wire. The live wire carries current to the device at a high voltage. The neutral wire completes the circuit and thus carries current away from the device to the source. The third wire, known as earth wire, that means green or yellow color, is a safety wire and connect the metal case of the device to the earth. This stops a fall, making the case of the device live. Okay. If a fall occurs when the live wire connected to the case, the earth wire allows a high current to flow through the live and earth wire. This overheats the fuse, which melts and breaks the circuit. In this way, it protects the circuit from catching fire. I hope all of you understand this live wire, neutral, and earth wire. Okay. And the next is household conceptions of electrical energy. You know that electric power is generated at the power generating stations. These stations are generally located very far from the areas where it is consumed. To supply electric power to a house, either the overhead wires or cables on the poles or an underground cables is used. To connect the cables from poles to the meter in the house, first a fuse of high rating is connected in the live wire just before the meter. After this fuse and the cable connected in an electric meter, the main fuse is connected to the live wire where the main switch is connected to the live and neutral wire. So the electric meter is fixed at the main board or the just outside every house for measuring the amount of electrical energy consumed by various appliances in the house over a certain period of time. The consumer pays the cost of electrical energy consumed in unit of kilowatt hour. That you use that unit of power. The amount of energy consumed when an electrical appliance of power 1 kilowatt is used for 1 hour is called what? 1 kilowatt hour. Total energy consumed by an electrical appliances in kilowatt hour can be calculated by multiplying its power rating with time durations in hour for which it was used. Then the cost of electrical energy will be the product of energy consumed in kilowatt hour with the rate in rupees per kilowatt hour. The consumption of electric energy can be calculated in, that you know that, yeah, power multiply time. Power multiply time. Okay, upon 1000. So like this way we can able to calculate the electric energy, how much we are consume in our home. Okay. We are going to discussing the precautions in using household electrical appliance. What are the precautions we have to take? Yeah, first one, do not put your finger or any metallic objects in the sockets. Okay, do not touch the switches on main board. This is the job of electrician. Actually, the main board switches touched whom? Electrician. Okay, do not touch metal parts of any electric appliance such as table fan, heater, fridge, air cooler with bare hands when they work. Do not touch switches with a wet hands. Always use 3 pins plug for movable appliances. The bigger pin in this plug is earth connection. It protects the user through receiving an electric shock. While ironing clothes, always stand on a rubber mat on a wooden board. Do not try to repair an electric circuit by guesswork. Without knowing, don't repair any electric circuit. Okay. And always use a good quality insulating tape while joining copper wire. Do not touch electric poles with bare hands, especially in the rainy season. Sometimes the current leaks through them and can give nasty shock. So this is the precautions in using household electric appliance. Okay, clear? Yeah. And the next is conservation of electricity. Electric energy generated by burning coal or natural gas in thermal electric power stations. Electricity from water is generated by setting up huge dams across the rivers at suitable places. So the electric energy so generated costs a lot as huge expenditure is incurred in setting up thermal electric stations or hydroelectric stations. Electric energy should be used when it is absolutely necessary. It is wisely said electric energy saved is electric energy generated. So at homes, only those appliances should be used which are absolutely necessary. It is of no use to put on all the fans and bulbs at night. When all of you are sitting in the room, similarly use televisions only when you are watching it. In big hall, use only those power points which people are sitting. It is of no use if 20 fans are working and there are only 5 persons sitting in the one corner of the hall. Street lights should be put off during moonlight nights. Use good quality wires as poor quality wire waste lot of electric energy. So dear students, these ways you can able to conserve the electricity. So today we are discussed about that is battery and safety components. That means what? Electric fuse, miniature circuit breaker and grounding that means earthing and live wire, neutral wire and earth wire. Then after we have discussed about what? Yeah, household consumption of electric energy. Then precaution in using household electric appliances. At last we have discussed conservation of electricity. I hope all of you understood this topic. Okay, thank you.